Thank you very much. So this is my talk, when Rotten Tomatoes isn't enough. So we're going to be analyzing Twitter movie reviews with DataStax Enterprise. So let's talk about what we're actually going to talk about. What problem are we really trying to solve here? So what we're going to do is an introduction to Apache Cassandra, what it is, why do I need it, a very quick introduction to Apache Spark, what it is, why do I need it. I have a strong feeling that this group is very familiar with these things, but we're just going to do a really light touch on both of these items, and then we're going to go into a live demo. And then we're going to talk about what is sentiment analysis, because we're going to do a little bit of data science here. We're going to do an overview of the demo I'm going to do, and then we're going to do an actual live demo. Alrighty, so you already heard enough about me, but this is a little bit about me. It's pretty much the same thing. Okay, so what problem are we really trying to solve here? We're trying to solve what movie should I see? So wouldn't it be great if I could ask 1 million people this question? Wouldn't it be even greater if I could automate this process? So basically, data analytics and data science doesn't have to be complicated. So we're going to utilize the power of big data using Apache Cassandra, Apache Spark, the Spark machine learning libraries, Jupyter Notebooks, Python, PySpark, which I didn't mention here, Twitter Tweets and the Twitter Dev API, and we're going to use Pattern, which is actually a Python package for sentiment analysis. Okay, so we're going to do the world's briefest introduction to Apache Cassandra. All right, what exactly is it? And this group, again, Apache Cassandra has been around for 10 years, so this group is probably pretty familiar with what it actually is, but let's just do a high level for people who aren't familiar with it. It was developed by Facebook, again, about 10 years ago. And it became a top-level Apache project in 2010. So here's the key. It is a distributed, decentralized database. These are the key words that you need to keep remembering. So it's elastically scalable. You can add and remove nodes with no downtime. It has very high performance. It's very fast. It has high availability and fault tolerance. There is no single point of failure. And we're going to talk a little bit about that here in the next couple of slides. And it solves many of the problems that you might face with a traditional database for certain workloads. All right, so I work for DataStax. So I just want to do a quick just little plug for DataStax Enterprise. Basically, they have a lot of the key contributors to the Apache Cassandra project, and it's the commercial product around Apache Cassandra. It has a lot of cool features, more QA, and more support. And actually, the demo that I'm going to do for you is actually just a one-node DataStax Enterprise Analytics node just here on my laptop. All right, so what does this all mean? So let's talk about 4 big topics. We're going to talk about distributed, replication, elastically scalable, and high availability. Now, like I said before, this is a super brief intro. So for more information, we actually have, it's called DataStax Academy. It's actually totally free courses on all these things I'm going to talk about and way more. So if you're interested in any of the things I'm talking about, check this out. It's totally free. All right, so distributed. Every node in the cluster has exactly the same role. And I put here, really. Because sometimes you kind of hear about these things and you're not sure if they're actually true. But this is actually true. Cassandra does not have a master worker architecture. So every client can connect to any node because every node is exactly the same. All nodes are available for reads and writes, and they're all ready. But this is not to say that all nodes have all of the same data. That's not very scalable. All right, so replication. Here we are. We're talking about the data and where it resides. So to be able to survive a node going down, data must be copied to other nodes. So if any of you, I mean, we're all big data people. You're all familiar with HDFS. You're all familiar with these types of things. So replication factor is something you're very used to. But this is something that's set by the user. So in Cassandra, you can set this anywhere from just 1, I just have 1 replica of my data, up to the number of nodes that you have in your cluster, which is not actually recommended, but you could do it if you want to. Normally, the recommendation around replication is 3. So the data is asynchronously replicated automatically. So there's peer-to-peer communication. All right, so elastically scalable. So the more nodes that are added, the performance actually increases linearly, which is important because not only can you add the nodes, but you're getting that increased performance. So you can scale up and scale down with no downtime. You don't even need a restart to add nodes. And the reads and writes both scale. All right, so high availability. This is kind of one of the key points besides the distributed decentralized database. But the lack of the master node allows for high availability because there is no single point of failure. So replication allows nodes to fail and data to still be available. So Cassandra expects nodes to fail. That's what it was built for. It has this already built in. It knows it's going to happen, and it doesn't panic when it does happen. So it also has multiple data center support right out of the box. You can just have a US data center and a Europe data center very easily. It just has to be configured in a YAML file. All right, so one small trade-off, because I've been talking about all the amazing things of Cassandra, and I know sometimes people get up here and they want to talk about their product and how amazing it is and how magical, but we do have one small trade-off, and it is very small, but I want to bring it up, especially for a tech crowd. And this all evolves around the CAP theorem, which is, if you don't know about it, you should Google it. It's actually very interesting, but it's about availability, consistency, and partition tolerance in a network. So basically, a database cannot have all of these. It's impossible. You can't have all three, and you can see in this chart here. So what Cassandra decides to do is it wants to be highly available. And so because of that, it chooses that it's going to have eventual consistency. So that's the default. But you can prioritize your consistency of your data over availability. So these are all configurable things. It's just really about what's important to you. Think about whether you have data that's important to you or data that maybe is not as important, like likes on a Twitter tweet. So like I said, the consistency levels are configurable. So you can have, and here's another easy equation, is that the write consistency plus the read consistency, as long as that's greater than your replication factor, you have strong consistency. Okay, so why would I need Apache Cassandra? So basically, in this group, I think you pretty much have a really good understanding of this. But if you have a big data, do you need to be able to read and write fast? Do you need to be able to scale up and scale down easily? Do you need high availability, which you probably do? Do you need multiple data center support for your application? Do you need multi-cloud or hybrid cloud support? If you need any of these things, you probably need Cassandra. All right, now this is the world's quickest introduction to Apache Spark. Okay, so what is Apache Spark? Apache Spark is a unified analytics engine for large-scale data processing. So I'm just going to highlight this term right here, analytics engine. It's going to help us do our analytics, especially here in this demo. So it's 100 times faster than Hadoop, and it utilizes in-memory processing and amazing parallelism to actually get that. And so we're going to be talking about, it has quite a few things that Spark has, but we're going to be talking about the machine learning libraries. Okay, so why would you need Spark? Again, this is a super quick, light intro to Spark. If you have big data, do you need high availability? Do you need analytics at lightning speed? And if you need insights into your data, you might want to consider using Spark. Okay, so now we're going to start talking about kind of the overarching thing of this talk, which is the Twitter movie reviews. So what is sentiment analysis? What are we going to try to do here with data science? Okay, so at a very high level, now you could talk about sentiment analysis, probably could have whole courses on it. But for this case, we're just going to talk at a very high level, and it's very simple. It's basically natural language processing and text analytics to determine if a word in a sentence is positive, negative, or neutral. So this is very easy for us to understand at a high level, but it's very difficult for machines to learn how to do. But also think about us in this day and age with text messages. Think how difficult it is, even when like somebody sends you like a text message and they say hi and they put a period. Right? You have to figure out what that person means. Are they happy? Are they neutral? Are they sad? So even for us, it's getting more difficult to understand what people actually mean with what they type. So imagine for a machine to try to figure that out. Okay, so let's do an overview of the demo. Alrighty, so what we're going to do is I have a local DataStax Enterprise analytics setup here on my laptop. It's just a one-node cluster. I have a local Jupyter notebook set up here on my laptop. So we're going to pull Twitter data on a movie title. So in this particular instance, we're going to use Mission Impossible. We're going to clean up the tweets. We're going to insert that data into Cassandra. And we're going to create a Spark data frame from that. Because DSE analytics, which I didn't really talk about here, but it has that all integrated right in the box. And you'll see how easy it is for us to move from Cassandra to Spark. We're going to use Spark machine learning libraries. We're going to do sentiment analysis with Pattern, which is a Python package, and it's going to give us the positive or negative. We're going to take an average of all the scores, and then we're going to decide, should I actually see this movie or not? Okay, so let's get to the demo. All right, so it's a Jupyter notebook, and I can make it bigger. So it may be a little bit difficult to see in the back, but I do have this on my GitHub, and anybody's free to download it. So let's just start walking through this Jupyter notebook. So I have Again, if you wanted to download this from my GitHub, I have all the steps on what you would need to do to actually get it set up and just running on your laptop. So we won't walk over through those. It's not that interesting, but it looks like it's a lot of steps, but it's actually the complete amount of steps. It probably would only take you 20 minutes to get this all set up and running. These are just some environment variables that you would need. You import some packages in Python. This is just a helper, nice function to do some like nice formatting, pretty printing for Spark data frames. All right, so now let's get to DataStax Enterprise Analytics. So we're going to create the table, we're going to pull the tweets, and we're going to load the table. So we're using the DataStax Python Cassandra driver. And so here, this is all we need to do to actually connect to our cluster. And like I said, it's a one node cluster just running here on my laptop. So I'm just connecting to localhost here. I get my cluster object and I'm able to create a session just that easily. From there, we're actually going to create a key space. Now, a key space in Cassandra is similar to, if you're familiar with Oracle, it's like a schema, or if you're familiar with Teradata, it's like a database. And so we're going to set that up. We're going to use a simple strategy, and we're going to use our replication factor, which I talked about before. We're just going to set that to 1 because there's no point in replicating my data because I only have one node. And next, we're going to actually just set our key space. And now we're going to set up our movie title. So in this case, we're going to search on Mission Impossible. And we're going to search for positive tweets and negative tweets. So we're going to create 2 tables in Cassandra for this movie title, one for the positive and one for the negative. So Twitter, actually the Twitter Dev API, if any of you are familiar with it, it's actually really awesome. You can get a ton of real-time information about basically anything you want to search for. So it actually gives you a ton of information, way more than we need for just the sake of this demo. So we're just going to utilize the Twitter ID as our primary key to what actually we want to partition our data by because it's unique. And then we're going to get the actual tweet. So just a little note here, you may want to think about when you're actually distributing your data at scale with Cassandra, if that primary key of your Twitter ID is really the right thing to partition by. In this case, because I just have one node, it doesn't really matter, but it is something to consider, like for your data model, when you're choosing your primary key. So we're going to create both of those tables. So from there, we're going to actually set up our search terms for gathering tweets from the Twitter API. So what's really cool about Twitter and their APIs, what I noticed when I was working on this demo, is they actually do a first pass of sentiment analysis on the Twitter tweets. And you can actually search that literally by a happy face or a sad face. And it's actually true. And they will give you back either positive tweets or negative tweets. And we'll see as we go through this, actually their first pass at it with the positive tweets is spot on. You almost always get positive tweets. For some reason, whatever algorithm that they're using for the negative tweets, you don't always get negative. I'm not quite sure why. I've been playing with it now for a couple weeks. It doesn't really seem to work, but the positive seems to be spot on. But we'll see more about that as we walk through this. All right, so now I'm going to have another function here that's actually going to clean up the tweets. We're going to remove the emojis, flags, special characters, URLs, and we're going to remove RT because when you pull in the Twitter data, it actually for retweets, it just puts this RT in there. I just removed it just to make it a little easier for the sentiment analysis function, just in case so it wouldn't get confused. And actually it would be pretty great if we could do sentiment analysis around emojis because a lot of emotion comes through with those emojis. But in this case, we just remove them. Alrighty, so then to be able to use Twitter and their API, you have to set up some keys and things like that, and they walk you through it all in their URLs and their links. So I got that all set up here. All right, so this cell, we're actually gonna pull the tweets from Twitter. So the maximum number of tweets you can pull at any one time for free is only 100. So you can actually run this code a couple times to pull more and more. So once the tweets are collected, let's loop over the list, clean up the tweets, and then insert them into the table. So we have a large for loop around here that surrounds this to make one call for the positive and one for the negative. And then we also have to URL encode our happy face and our sad face. So that's what this is doing here. And because this is a very techie crowd, you'll notice I have a comment here. I actually have a comment on the actual insert. We're actually not going to insert this because I already found some really great data that I wanted to show you. So even though if we could pull it live, we're not inserting it into the table. So we're seeing actually some of the tweets that got pulled live just when I ran this just a little bit ago. And these are all about Mission Impossible. So then we can do a select star in the table and verify that the tweets were actually inserted into our Cassandra table. And so we can see here that they were. So let's scroll down. All right, so now we're starting to get to some analytics with Apache Spark. So now it's actually time for that. So what we're going to do in this one line of code here is we're able to take our Apache Cassandra table and load it into a Spark data frame. And so we're going to create two Spark data frames, one for positive tweets and one for negative tweets. And just this one line of code right here will move all the data from Cassandra into Spark. Now, really, I think, again, this is all just around one node, but imagine this at scale, right? And how easy that was to do. And then we're just going to take a count of how many rows I got for each. So it looks like I have 50 tweets for the positive and 75 for the negative. So now we're going to actually use those machine learning libraries to break up the sentences into actual words. So we're going to use the Spark tokenizer, and it's going to cut up the sentence into individual words. And we're going to do that for the positive and for the negative. And you can see we just print out the data frame here. It shows the tweet, when it's cut up into words, and then how many words were in each tweet. All right, so then the next thing that we're going to do is we're actually going to remove all the stop words. Anything that has, like, if you're familiar with of, a, the, none of that's actually important to the sentiment. So we're actually going to strip those out. And so we're using, again, the Spark machine learning library stop words remover, and we're going to do that again for the positive and for the negative. And so we can already start seeing some interesting things here. We see the number of tokens that are originally, so number of words in each sentence, and then once we remove the stop words, how many words we have left. All right, so now let's actually get to our sentiment analysis. So we're going to convert each Spark data frame to a Pandas data frame. Now, I just want to let everyone know that this works as is because I'm working on my laptop. Anyone who's familiar with Spark and data science and big data knows that Pandas just runs locally wherever you're running it from, be it your laptop or server. So to just move from one to the other, you have to make sure that when you're moving from one to the other, that you have the memory to actually do that. So again, it just works because it's here on my laptop, but it's something to consider. So then we're going to loop through each of the rows, and we're actually going to get a sentiment score, and we're going to get on each tweet, we're going to get whether it's positive, so it's like a positive number, or it's negative, which means it's a negative sentiment, or we'll get a 0. 0 can mean neutral, or 0 can mean I don't have enough information to score this. I really don't know what it means. So then we're actually going to have the assessment function, which is part of the pattern package, and it's going to show whether the word what words that we use to judge whether this was positive or negative. So here's the Python code here for this. So okay, so these are some of the tweets that we've gotten. So here's an example. I want to watch Mission Impossible. Has anyone watched it yet? And then a sad face. So it's not really a movie review, but it is a real-time tweet that I just pulled not too long ago. And so this, in this case, it got scored as 0.3. So kind of a negative sentiment. All right, so we have here's our nice data frame here printed out. We have our original tweet, the score, whether it's positive or negative, and why we decided that score that we did, so the assessment. So straight away, we're seeing something interesting here on our assessment. We're seeing the word impossible. So we'll come back to that here in a bit. So let's do the same thing with our positive tweets. And actually, and another thing I forgot to mention is as we go through, we're actually taking an average of the scores so that we can kind of make a rough estimate of whether we should see this movie or not. So here's like Mission Impossible Fallout is great. So we got a 0.8, so that's a very positive feeling about that. And we can see straight away in our assessment that it gave the word great. And it said, okay, that's why I'm going to weigh it so highly on the positive, because great is such a positive word. Alrighty, so we're finally to the end here. Should I see this movie? So basically how I'm saying in just my demo here is if the average of all the positive scores is greater than the average of the negative scores, I'm saying, hey, go out there, go see this movie, people like it. Or if they're equal, I'm saying, hey, go take a chance, people are split. And if the positive rating is actually less than the negative rating, I'm saying, oh, people don't like this movie. Alrighty, so our final positive rating score is 0.2. Not that positive. Our negative score is actually negative 0.4. So we're saying people don't like this movie. So is this the answer that you were expecting? So when we look at Rotten Tomatoes for Mission Impossible, it has a super high score. So maybe we need to, either way, we really need to go back and take a look at our data. Data science is an iterative process. So let's kind of scroll back up here to those negative reviews that we saw. What do we keep seeing over and over again in our assessment? The word impossible. Now, because Mission Impossible is in the movie title, maybe I should have removed that when I was removing my stop words, right? Because the movie title doesn't have any weight on the actual assessment. It's just there, it's the movie title. So because we had that word impossible, it feels like it's really negative. So if I had removed that, then we would probably get something much higher for the positive and the negative, because it wouldn't have those negative words. So here's just some important links so that you can learn more about Cassandra and Spark and DataStax. You can also follow me on Twitter. And our team is just recently, we're getting involved with live demos on Twitch. So feel free to check that out. Like I said, this is on GitHub. And definitely check out the DataStax Academy, because all this information is totally free. Thank you.